You and welcome to all of you to Unacademy and welcome to my class. Before I start, let me just confirm that whether am I live or not. Everything is clear or not, audio as well as video. If everything is clear, just let me know. Just let me check once. Check once. Okay, so I think I'm live. So today is 19th of October 2021, Tuesday, and we are going to take a live mini mock test. The mini mock test on atomic and molecular physics. So, guys, on every Friday we take this class, but today, especially, we are taking it on Tuesday. And you can also watch the previous test. We have taken previously the live mock test on atomic and on electronics, on quantum mechanics, on thermodynamics, and electromagnetic theory, mathematical method, etc. So you can also watch those previous live test, and you can also get the links on our group also. And guys, let me before I start, let me tell you about some of the great features of Unacademy special classes. So, Unacademy special classes are completely free for all the learners. You just need to install the Unacademy Learning app, and you can watch all the videos, special videos, free of cost. You get interactive live classes. You get the poll option. You get the option to raise your hand. You never miss a class because you get notifications regularly, and you get the lecture notes in the form of PDF, and you can watch these classes anytime, anywhere. And guys, these recorded classes are also available. If you visit my profile, you will get these recorded classes. You can search with my name, Sahin Sorifi, SAHIN and you will get my profile. And upon visiting my profile, you will get a lot of recorded special classes to watch anytime. And you can also see the upcoming special classes there. And guys, currently this course is going on Unacademy Plus. We are taking it in the morning at 7:30 a.m. Detailed course on electromagnetic theory. So you can enroll for this course and you can attend this course. This is a detailed course, complete course. The whole electromagnetic theory syllabus will be covered here. On Unacademy, you get the facilities of weekly test, special test, and guys, a special offer is going on. This mega offer on CSIR NET subscription. If you take the Unacademy Plus subscription for 24 months, you will be given 3 months extra validity. If you take this by 20th of October, you can utilize this referral code Sahin Live SAHINLIVE to get 10% off on overall fees. And for the 6 month subscription, the same referral code will be applied. And here, within this 20th of October, if you take the subscription, you will get 1 month extra. So you can think of taking this plus subscription. And Iconic subscription is also there. You get different facilities of Iconic subscription. You get personal coach, you get study planner session, study booster. So plus benefits you will already get. You'll always get, and in Iconic you will get some additional benefits. Now another great feature have been launched, guys. You can just ask your doubt. You can just click a photo of your doubt, you can post it on an Academy Learning app, and you will get the solutions. So that feature will help you to clarify your doubt more efficiently. You can utilize our referral code SignLive for getting 10% off on overall fees. Now, without further ado, let's just start. So today's mini mock test will be on atomic and molecular physics. And today I have already shared the PDF of the question paper on different social media, Facebook, WhatsApp, and Telegram. Also, you can also download the PDF of the question paper. Those who do not have, uh, those who do not have the question paper, you can see it. I have also attached the question paper here. So let's start with the first question. Before I start, let me know if everything is clear or not. Can you hear me properly? Can you see me properly? Are we ready to go? So this is the first question. You can see a mixture of ordinary hydrogen and tritium is excited and its spectrum studied. The shift in wavelength for the H alpha lines of the two kinds of hydrogen atom is. Okay. So for hydrogen, you will get some H alpha line. For tritium, you will get some H alpha line. So you have to find out the shift in their wavelengths. Can you do this problem? H alpha line means what? H alpha corresponds to the transition from n equals to 3 to n equals to 2. This gives you the H alpha line. Now you have to consider hydrogen means 1H1 and tritium means 1H3. These two atoms you have to consider. You have to find out the H alpha line for both of them, and you have to find out the shift in their wavelengths. So this is the first problem given in the assignment. Can you do this? So let me give you some hint. So how can you solve this problem? You know the wavelength which is emitted during such transition is given by this formula 1 by, let's say we are calculating for the hydrogen atom. So 1 by lambda h, this will be given by R, Rydberg constant for h, and as it is coming from n equals to 3 to n equals to 2, n equals to 3 to n equals to 2 is coming. So this will be 1 by final square, means final is 2. Here n initial is 3, n final is 2. 1 by nf square minus 1 by ni square means 1 by 3 square. This will be for hydrogen. So this is, what will it give you? 1 by 4 minus 1 by 9. So this will give you 5 by 36 times RH. RH is the Rydberg constant for hydrogen. So same thing we can write for tritium. So this will be R for T, 1 by 2 square minus 1 by 3 square. The same transitions we are considering. This is for H alpha 9. So this will also give you 5 by 36 R. Okay. Therefore, what you can write from the first relation, we can write lambda h is equals to 36 by 5. Okay. RH. From the second relation, we can write lambda t is equals to 36 upon 5 of RT. RT. This will not be the case. So we got the wavelength lambda h and lambda t. If you take the difference, that will give you the shift in wavelength. So lambda h minus lambda t we have to find out. So this will be giving you 36 upon 5 into 1 by RH minus 1 by RT. Okay. So now we know the variation of Rydberg constant with mass. That formula we have to utilize. So 36 by 5. We know the formula for Rydberg constant variation. RH is equals to R infinity divided by 1 plus mass of electron divided by mass of that particular atom image minus 1. This will be giving you R infinity divided by 1 plus m by mt. We have already discussed this Rydberg constant variation in our special class. Gaurav, you are getting C. C, yes, C will be the answer. Yes, you are right. C will be the required answer. So this will be giving you 36 by 5 into m upon R infinity. देखो क्या मिलेगा ये into 1 by mh, this is capital M, this is capital M, minus 1 by mass of tritium. And you know the relation between the mass of tritium is 3 times the mass of hydrogen. Sorry guys. So you can just put the value 36.66 by 5 into m by r infinity into, if you put mt is equals to 3 times mh, so this will give you 2 by 3 times mass of hydrogen. If this is so, you just know all the values now. Okay, so 3 will be 12, so 24 by 5 into m by r infinity into mh. What does this value give you? 24 by 5 mass of electron at r infinity 1.097 10 to the power 7, and this mass of proton is 1836 times mass of electron. So this m by mh is basically 1 by 1836. So if you calculate, what will you get? Let's calculate 24 divided by 5 into 1.097 10 to the power 7 into 186. So I'm getting 2.38 into 10 to the power minus 10, and as it is a wavelength, so the unit will be meter. 2.38 10 to the power minus 10 meter, and that is equals to 1 angstrom. 3.28, sorry, 2.38 angstrom, because 1 10 to the minus 10 meter is equals to 1 angstrom, and it is correctly matching with option C. So I hope this is understood. Okay, so let's do it. After this, we'll go for the next problem. Okay, let's move forward to the next problem. Where is the next problem? Yes, this is the next problem. The emission wavelength for the transition 1D2 to 1F3 is 3122 angstrom. The ratio of populations of the final to the initial states at a temperature of 5000 Kelvin is. You are given the value of the Planck's constant, velocity of light, and Bolman constant. Okay, you have to find out the ratio of population of the final to the initial states. So let's say this is your initial state, this is your final state. Initial state is 1D2, final state is 1F3. Okay, and emission wavelength for this transition is 3122 angstrom, and let the gap, this gap, let's say that is delta E. Kitna fingers ho gaye? Okay, you have to find out the ratio of population of the final to the initial state, and temperature is given. Temperature is 5000 Kelvin. Can you tell me what is the value of J here? J is equals to 2 here, and here J equals to 3, because you know this is the spectroscopic term, you can say 2s plus 1 Lj. This is the representation. That is why the J value is 2 here and J value is 3 here. So you have to find out the ratio of population of the final to the initial state. AGF, sir, can any experience required for part-time PhD in a state university through accept exam, APCAT exam? Okay, how can we proceed for this exam? Experience is not required generally. If you have experience, you will get some extra benefits. Otherwise, this experience thing is not mandatory. Okay, if you can crack the interview, then if you have some supervisor who is willing to take you as a PhD student, then you can easily go for it. Experience doesn't matter. It's on YouTube. I think you are subscribed to that channel, so don't worry. So let's solve this problem. Okay, we have to find out the ratio of the initial population, final population to the initial population. Can you do it? आप लोग कर पाइए? If not, then just look at the solution. So you know the formula of population n of ji means population of the initial state divided by the population of final. So ratio is given by, it is depend upon the multiplicity, which is 2ji plus 1 divided by 2jf plus 1 into exponential. You see, for this gi, this will be minus ei upon kbt, and for the final state, it will be exponential minus ef upon kbt. So this is the formula actually. So we can write it in this way: 2ji plus 1 divided by 2jf plus 1 exponential. We can write it in this way: minus ei minus ef upon kbt. Simple till now? No. So this ei minus ef is what? 2ji plus 1, 2jf plus 1 exponential minus, this is delta E. Okay, this ei minus ef is given by delta E. That is given in terms of the wavelength 3122 angstrom. So you can directly put that value. So here we have been given the delta E value. Delta E is nothing but the difference between j equals to 2 and j equals to 3. So E is equals to, hc upon lambda. Lambda is given, which is 3122 angstrom. So you can easily put that value of lambda. And then what will you get? Therefore, your value nji upon njf, what will be its value? 2ji plus 1 divided by 2jf plus 1. Okay, here ji is equals to 2, jf is equals to 3. You should know about it. Exponential minus the delta E is equals to hc by lambda, so it becomes hc by lambda kbt. Fine. Why in A energy Ej proportional to j plus 1 and not by j and the interval rule? No, no. This relation is given actually. It is proportional to the multiplicity of that level. 2ji plus 1, 2j plus 1 exponential minus e by kbt. This is known as this is Maxwell-Bolman relation. No? That is another thing. That whatever you are saying, anti-interval rule, that is different thing. This is given by Maxwell-Bolman rule. You can see it in. You can go through that Rajkumar's book. It is given there. Okay. Population is proportional to this multiplicity factor times this exponential minus a by kbt. ये आपका, this is given in molecular physics actually. So just put the values. Okay. So ji is equals to 2. So 2 into 2 plus 1 divided by 2 into 3 plus 1 exponential minus ac by lambda kT minus h is 6.626 into 10 to the power minus 34 joule second. C is equals to 3 into 10 to the power 8 meter per second, and lambda is given to you 3122 angstrom, 1 angstrom 10 to the power minus 10 meter, and kbt, you know the value 1.38 10 to the power minus 23, and the value of t is given to you 5000 Kelvin. So 5000. Simple. So this is becoming 5 by 7 exponential. If you calculate this whole thing, what will you get? Can you calculate? Yes, KGF. This is the formula we know. Population is directly proportional to 2j plus 1. Okay, multiplicity of the level of that particular level. 6.626. Just calculate it. What value are you getting? Let me know. I'm getting 9.227. So minus 9.227. So exponential of this thing, what will be its value? Exponential कहाँ गया यार? Exponential of the answer into 5 by 7. So what are you getting? 7.02 10 to the power minus 5. Okay, which is matching with option C. C के साथ मैच करा ना? हाँ. Option C will be the correct option, guys. So I hope this is done. Let's move forward to the next problem. Next problem is quite easy. Okay. Okay, this is the third problem. The number of spectral lines allowed in the spectrum for the 3 2D to 3 2P transition in sodium is. A very good problem. ये में ड्रॉ करने का कुछ है नहीं क्या? Do this, guys. इसका आंसर क्या आ रहा है? कितने ट्रांजिशन होंगे? Number of spectral lines allowed in this spectrum. So one you have 2D. Let's say this line. Another one we have 2P. Let's say this line. We have to find out the number of spectral lines. 4. Is it 4 or 3? SPD 0, 1, 2. P corresponds to SP means L equals to 1, and J will be possible values of J if it will combine with this for the above one. So 2 plus half maybe one case. So 2D 5 by 2 maybe one of the state. Another one maybe 2D 2 minus half, which is 3 by 2. Okay. Next 2P. 2P will be divided into two parts. So this half will now combine with this L equals to 1. So 1 plus half is 3 by 2. So 2P 3 by 2 J possible J values, and 2P 1 minus half is half. So these values will be there. Okay, so option C or B होगा. देखो, what are the selection rules? What are the selection rules? Delta L is equals to plus minus 1. Delta S is equals to 0. Delta J is equals to 0 plus minus 1. Okay. J is equals to 0 is not equal. Transition J to 0 to 0 is not allowed. Okay. So अब देखो कौन कौन सा ट्रांजिशन मिल रहा है. First of all, 5 by 2 to 3 by 2. So 5 by 2 minus 3 by 2 is 1, so that is allowed. Okay, 3 by 2 to 3 by 2. This is 0. This is also allowed. And 3 by 2 to half. This is 1. This is also allowed. Is there any other line allowed? Anomalous? Anomalous? No, no, no. 0 to 0 is not allowed. Yeah, anomalous कहाँ से आ गया? It is under, this is the selection rule. Selection rule in case of sodium or alkali atoms. Sodium or alkali spectra. So how many lines you are getting? Total 3. So option B will be the correct option for this question. Is it understood or not? Should I move forward to the next problem? Just let me know once if it is done so that we can move forward to the next problem. Okay, so let's move forward to problem number 4. Okay, so this is the problem from molecular physics. You can see the spacing between vibrational energy levels in CO molecule is found to be 8.44 × 10⁻². You have to find out the force constant of the bond in carbon monoxide molecule. Basically, value of K you have to find out. Can you do it? Can you do it, guys? Let me know the answer in the comment. Giving you a few minutes to this, to think about it and have the solution. 2d 5 by 2 to 2p 3 by 2 gives 1. Yes, so delta J is equals to plus minus 1 are allowed now. These values are what? ये क्या value है? What are these values? These values are J ना? Why are you considering these values of J? How do you write the spectroscopic symbol? 2s plus 1 L J. So we have applied J delta J equals to 0 plus minus 1. 5 by 2 to 3 by 2 it is 1. Okay. 3 by 2 to 3 by 2 it is 0. And 3 by 2 to half it is 1. So this is satisfying. And there are no other transition other than this. If you consider 5 by 2, 3 by 5 by 2 to 3 by 2, 5 by 2 to half, that will become 2. That is not allowed. So that is why the total number of allowed lines will be 3 in this case. Here, KGF. Now do this. 187 nanonewton per meter. Yeah, that's the correct answer. Let's do it. So spacing between vibrational energy levels in carbon monoxide molecule is found out to be 8.44 × 10⁻² electron volt. Reduced mass mu is given, Planck's constant is given, and 1 electron volt is also given. Force constant you have to find out. So you know the energy level of harmonic oscillator. What is the energy level of harmonic oscillator? Before we get the spacing, we need to know about the energy level of harmonic oscillator. It is given by EV is equals to V plus half H nu, H V oscillation. This V is nothing but the vibrational quantum number. Okay, and this V oscillation is given by 1 upon 2 pi root over K upon mu. So this K you have to find out. Mu is given. Mu is equals to 1.414 10 to the power minus 26 kilogram. This is given to you. You have to find out this value of K. Okay. So you know, in case of this harmonic oscillator, we get the equal spacing. And what is that spacing? In harmonic oscillator, this is equals to H nu. Okay. This is the spacing, equispaced energy levels. These are the equispaced energy levels. That value It is given in the question 8.44 into 10 to the minus 2 electron volt. In terms of electron volt, it is given. So we can easily convert it into joule. 8.44 10 to the power minus 2. If you multiply with the electronic charge 1.6 10 to the power minus 19 coulomb, you will get it in joule, and that value will give you 8.44 into 1.6 kitna hota hai guys? 8.44 into 1.6 gives you 13.504 into minus 2 minus 19 minus 21 joule. So we have expressed the spacing in terms of joule. Now force constant can be easily found out because we get this h new value, so new v value, so we can easily find out. Okay, so therefore delta ev will be equals to h into new oscillation. New oscillation is 1 by 2 pi root over a by mu. That's it. So we know the left hand side already. So we can find out the value of k. K will be nothing but 4 pi square mu delta EV whole square divided by h square. That's the thing. Now what is the value? 3.14 whole square. Mu की value कितना है guys? It is given in the question itself. 1.14 into the minus 26 kilogram. 1.14 into the minus 26. Delta EV is whole square 13.504 10 to the power 21 whole square. Kind of lengthy calculation, guys, but still 6.626 10 to the power minus 34 whole square. So if you carry out this calculation, why don't we consider delta j equals to -1? -1 कैसे होगा? Initial to final. Delta is basically the difference. माइनस कहाँ से आ रहा है? कौन सा वाला माइनस आ रहा है आपका? माइनस तो एक में भी नहीं है, पॉजिटिव टू नेगेटिव आ रहा है ना. यू आर कंसिडरिंग द ट्रांजिशन स्पेक्ट्रल लाइंस. आप उल्टा करोगे क्या? हाफ टू 3/2 करोगे? गायत्री बताओ, व्हाट इज द कंफ्यूजन? इनिशियल माइनस फाइनल. यू आर कैलकुलेटिंग डेल्टा जे जे आई माइनस जे एफ. तो लेट्स कंसिडर एनी वन. 5/2 से आ रहा है 3/2. कितना हो रहा है? 2/2 1 प्लस 1 -1 एक भी में नहीं होगा. 3/2 to 3/2 0 and 3/2 minus half is 1. So that is why everywhere delta j equals to +1. There may be some cases where it can be -1, but in this case, for this particular question, it is not there. Okay. तो इसका वैल्यू कितना आ रहा है गाइस? आलिया 186.933. 186.933. Okay, I am taking your answer. Newton per meter. I am not calculating it. You have calculated, so approximately 187 Newton per meter. So which option is it matching with? C. Okay. So option C is the correct option for this question. Let's move forward to the next problem. Problem number 5, guys. Are you ready for that? Question number 5. Just see it once. An atomic transition line with wavelength 300 nanometer is observed to be splitted into 3 components. To be splitted. B के बाद third form use होता है guys. To be split it into 3 components in a spectrum of light from a sunspot. Adjacent components are separated by 1.5 picometer. Pico means 10 to the minus 12. The strength of the magnetic field in the sunspot is, you are given the value of Bohr magnet, 9.17 it is given, but it should be 27. 9.27 10 to the minus 24 joule per Tesla. Just utilize this. Let me know what answer you are getting. Yeah, Gaurav, if you take 188.5, still the closest answer will be 187. Okay, so look, in many times you do not get the exact answer, so you should be choosing the closest answer. Okay, among the 4 options, whichever option will be the closest, that will pick up. अभी ये वाला क्वेश्चन करो. क्योंकि थोड़ा बहुत इधर उधर वैल्यू लेने से आपका जो आंसर है थोड़ा बहुत चेंज हो जाता है, तो दैट इज नॉट अ प्रॉब्लम. Solve question number 5. And guys, let me tell you once again, you can get the PDF of this question paper on our Telegram group, WhatsApp group, Facebook page, everywhere. KGF बोल रहे 1 आ रहा है. ये वाला क्वेश्चन थोड़ा सा कंट्रोवर्शियल मे बी. लेट्स सी. Three components splitting means a kind of normal geometric type thing. So delta E is equals to mu B times B. Delta E equals to HC into delta lambda upon lambda square. This is nothing but mu B upon B. Okay. So B is equals to HC delta lambda divided by lambda square mu B. Can you write it? Yes. Just put the values. H is 6.626 10 to the power minus 34. And T is 300 to the power 8. Delta lambda 300 nanometer. No? 300 nanometer, yes. Oh, adjacent components are separated by 1.5 picometer. So this will be 1.5 10 to the power minus 12 meter. Lambda is 300 nanometer. Okay. 300 into 10 to the power minus 9 whole square, and the value of mu b is given to you 9.27 10 to the power minus 24. कितना आ रहा है देखो, ये थोड़ा सा मे भी मुझे लग रहा है कि आंसर गलत है. 0.36. yes, as per देखो 0.36 आना चाहिए, ऑप्शन डी होना चाहिए. आप लोगों को क्या मिल रहा है देखो. 6.626 10 to the power minus 34 3 10 to the power 8 1.5 minus 12 into 300 10 to the power minus 9 whole square. 9.27 10 to the power minus 24 guys. Okay, so I'm exactly getting it 0.357, approximately 0.36 Tesla. ऑप्शन डी इज मैचिंग गाइस. आप लोगों को क्या मिल रहा है वो बताइए. अगर 9.17 लोगे तब आएगा 0.361. कोई भी ले लो, सेम आंसर. डी आंसर. यस, option D is the correct option for this question. Let me know when it is done so that we can move forward to the next problem. कितना time होगा guys? 9:42. Let's move forward. Let's go to the last problem. This problem is quite interesting. My favorite laser. In the helium-neon laser, 3-level laser, the energy spacing between the upper and lower levels E2 minus E1 is equal to 2.26 electron volt in the neon atom. If the optical pumping operation stops, the temperature at which the ratio of population of upper level E2 to the lower level E1 becomes 1 by 10th is closest. You have to find out that temperature. Okay. And those who do not have any idea, this is the helium neon laser. For your reference, I have attached this helium neon laser. You can see. So basically, the laser operation happens in neon atom. This helium atom just helps it to achieve the population inversion. Okay, and the main transition is occurred at 632.8 nanometer. This lies in visible region. Now, this is the main laser transition, and that we observe in case of neon. The main laser transition happens in neon. Helium just helps it to achieve population inversion. I know that population inversion is quite necessary. Mandatory, basically, not necessary, mandatory in case of lasing action. इसका बताओ आंसर क्या होगा। E2 minus E1 is given 2.26 electron volt. Okay. So now n of E2, number of atoms in E2 divided by number of atoms in E1 is equals to क्या होगा e to the power minus E2 minus E1 divided by KT. विलियम लियन 4 लेवल रह जाए। ओके, क्वेश्चन में 3 लेवल दे रखा है, कोई नहीं, आप इसको 4 ही समझो। एक बार क्रॉस चेक कर लेना, जस्ट क्रॉस चेक इट एट गूगल। इन द क्वेश्चन इट इज मेंशन 3 लेवल। ओके, ये में 3 लेवल ही दिख रहा है जैसे। एनीवे, that will not create problem in solving the question. A मिल रहा है 1.1. Yes, A will be the answer. So let's solve this question. Okay, so E2 from here what we can write, E2 minus E1 upon KBT. ये क्या हो जाएगा, ln of n of E1 divided by n of E2, and that is given to you E2 by E1, n of E2 by n of E1 1 by 10. So it becomes ln 10 because E1 by E2 are calculating. So basically your temperature will become Kb, so E2 minus E1 divided by Kb ln 10. E2 minus E1 is given in the question. Okay, 2.26 electron volt. So 2.26 electron volt. Kb, you know the value of Kb in electron volt, 8.265. 8.265 होता है 625 10 to the power minus 5. यह बता दो कोई, if someone knows it, confirmed 2.3. Is it 8.265 or 625? Kb means 1.38 10 to the power minus 23 divided by the electronic charge. 8.625. I assume that 8.625. इधर वो थोड़ा सा इधर उधर निकल जाता है ये 8.625. तो इसको कैलकुलेट करके क्या मिल रहा है गाइस, 2.26 divided by 8.625 10 to the power minus 1.2 10 to the power 4 Kelvin. It is matching with option. कौन सा option के साथ matching? So option A. So these 6 problems were there for this mock test, and I have shared the PDF of the question paper on our group, Facebook page, Telegram group. So you can just download that, and the solutions you can note it down from here. Already shared 3 assignments with answer keys on electromagnetic theory on our WhatsApp group, Telegram group, and Facebook page. You can also download them and you can also try. And if you get stuck in any particular problem, let me know. We'll try to solve those questions and we'll try to upload it on our YouTube channel. And guys, let me tell you, you can join me on Unacademy Plus for CSIR NET Physical Science preparation. A lot of benefits are there for in Unacademy Plus subscription. Some benefits have been listed here. You can just pause it and you can see them. I almost launch all the courses. All the 9 units I cover on Unacademy Plus, so you can join using our referral code Physics Hub or Sahin Life. My approach specifically, I precisely give you the concept of the constant topic, then I discuss the relevant mathematical formula, do the analysis. Relevant problem based on the topic, including previous year questions, are also discussed. Homework and assignments are also given. This kind of fee structures are available on Unacademy. Currently, this special offer is going on. 24 plus 3 and 6 plus 1. This is valid till 20th of October, tomorrow. If you are planning to take an Unacademy Plus subscription, you can take it. You can apply our referral code SAHINLIVE SAHINLIVE without any spacing, and Unacademy will offer you 10% off on overall fees. A lot of new courses is going to come, are going to come because your CSIR NET exam is approaching. Hopefully, in the month of December 2021 or in January 2021, you may expect your CSIR NET exam. So it's the time. Take 6 month subscription or 12 month or 24 month as per your requirement and financial condition, and you can join Unacademy and attend a lot of courses. One subscription will allow you to attend all the classes of all educators of all time. Okay, so this was all for this video, for this class. Thank you very much for joining this. We'll be taking the next mock test on next Friday. Okay, next Friday 9 p.m. My classes on this YouTube channel will be every Friday at 9 p.m. I take only one class per week on this YouTube channel. So till then, bye bye guys. Take care. Have a good night. Have a great health and take care. Bye bye. See you in the next class.